Hi and welcome to another very exciting tutorial. In this video we're going to have a look at Firestore again. Firestore is Google's new cloud database, which is really exciting, and we're going to build an app, a very simple app like Twitter, what you can see here at the moment. So this demo app is very simple. So I can press on this compose button, can enter a name here, and I can write a message like hello world. And I can send this message to the cloud right here. And this is nothing special actually, but wait for a second, because I have immediate synchronization, and I'm going to compose a new tweet now, or a new tweet as we call it here, from another device. And I'm going to call myself maybe Jamie, and I'm going to say, I cook something, and I'm sending this tweet right now. And immediately it's displayed in my list of suites. So this is just demonstrating how really fast Firestore is and how cool this whole new SDK and this whole new database really is. And I'd like to say, let's get started creating this demo application. And if you haven't seen my video on Firestore, on the basics of Firestore and how to integrate that with Xcode, then I suggest that you click on the info button in the upper right corner of this video and watch this video first, and then come back here and create this amazing application. And in order to save some time and get started right away, I have added a starter project to the video description below, which you can download. And this starter project contains this storyboard, where we have just a simple table view controller embedded into a navigation controller. We already have a reuse identifier for the prototype cells. We have an IB action connected to this bar button item, which leads to the table view controller, and here we have a compose suite IB action. And this is really simple code here, nothing fancy. We're just creating the compose alert, adding 2 text fields with some placeholder text. As you can see, if we open up the simulator again, there is this text field here. This has some placeholder text. We can click on cancel or send. So we have the cancel alert action, and we have the send alert action. And here I've added a comment because here starts the interesting part for us later. Also, what I've already done in appdelegate.swift, I've imported 2 things. I've imported Firebase and Firestore and called Firebase app.configure, which is responsible for establishing and configuring the connection between our application and the Firestore service right after our application launches. And this is because, or this is why we are actually putting this code in application did finish launching with options. And it is also important that before you continue with creating this application, be sure to actually install the Firebase or the Firestore SDK into your Xcode project, also in this startup project using the Podfile that is also available in the video description below. And as soon as you've opened your new Xcode workspace, you can actually follow along. Just one more piece of advice: there is the Google service info plist file that you have to download, but you've seen that if you've watched the last video. You can create that file in your Firebase console, and you have to download that on your own, because this is associated with your personal account. So this is not going to be included in the tutorial files. But now we can definitely get started, and I'd like to outline what we really plan to do, or maybe we can even start adding some code already. Because what we want to do is, when you remember what our application does, we are sending a suite, which is something like a tweet, and what we are associating with a suite is a name, a message, or content, and also we have a timestamp that you can see as a subtitle in these table view cells. And when you remember how we are storing data in Firestore, and you're remembering the data model from the last video, then you might also remember that we have 3 things that we need to consider, or 3 pieces of the data model. We have a collection, with document, and with data. And we could create a collection called suites, and in this collection we can store each suite individually. sequentially. And each suite has 3 pieces of information: the name or the sender, the content of the message, and a timestamp when this suite was actually sent. And you can see in this example here on the right that we're using key value information here. So we could use dictionaries or JSON to actually encode our data. And what we are going to do is creating our own data model to very easily work with our suites here in Xcode, and therefore we're going to create a new Swift file using some pieces of protocol-oriented programming. So I'm creating a new suite file here, create that. And what we're doing here are 2 things. So we're needing foundation, and we're going to need Firestore, and we're defining a struct here. So we're having a value type here, and our struct is going to be called suite. And we're having some properties here and also a computed property. We're going to start with the name. As I said, this is one part or one piece of information that we want to store. Also the content of the message, which is also a string. And we have the timestamp, which is a date object. And these 3 pieces of information should be encoded into JSON or using a dictionary. So what we can do is also defining a dictionary, which is of type string keys and any class or any type as a value. And to make that a computed property so that we can later call it and give Firestore a dictionary what it needs, we're simply adding a return here and encoding our information as a dictionary, starting with the name, which is the name. What we also have is the content, using content, and we also have our timestamp, using our timestamp. And that is our dictionary computed property. And now I said that we're going to use some protocol-oriented programming. So what we'd like to do here is, first of all, defining a protocol that lets us initialize our struct here. So I'm using a protocol here, and I'm naming it document serializable, which is going to be a type that can be initialized from a Firestore document. So here I am simply removing my spare curly braces, and I want an optional initializer here that can receive a dictionary as a parameter using, again, string keys and any type as a value. And now the cool thing about protocol-oriented programming is that what we can actually create a extension to our suite, adopt our document serializable protocol, and then add an implementation for our init with dictionary function. And here I'm creating now a got_let statement to check if, for example, I get a name using my dictionary, using my key name, immediately casting that to a string. Also checking if I can do that with content, using my dictionary, accessing it with brackets and a key content, casting that immediately to a string, and again, creating one last piece, which is our timestamp, and our dictionary, timestamp, and converting that to a date. And if nothing of that works, then we return nil. And if it works, which is cool, then we're using self init. We're initializing our suite with a name, content, and timestamp. Building that, and this suite struct and this extension with the document serializable protocol is going to allow us to really easily work with our suites together with Firestore. So we have a simple data model here, and we can now move into our table view controller and first of all create or import Firestore in our table view controller so that we can work with that SDK. And one important piece or one important object that we have to work with is our Firestore database. So I'm directly defining that as a global property here with Firestore. Let me just quickly build that so that we get code completion, and then I can use Firestore here if I would import Firestore instead of Firebase here. So just changing that here in the import statement. And now we have our database ready, but we also need to initialize our database. I'm doing that in view.load. Here I'm simply assigning Firestore and Firestar. With that, we can access our database. And now I'd like to add an array that is going to contain all of our suites after we created one, and also when we're receiving the list of suites from our database. So since we have our own data model for our suites, I can create a suite array and initialize that just with an empty array of suites. But we cannot actually receive any information if we haven't created any suites and sent that to our database. So let's scroll down a little bit to our compose suite function and to the interesting part that I marked with a comment here. And we first of all should check if we have the information available that we'd like to send to our cloud database. And therefore, I'm using an if-let statement here. We're going to need a name, and I'm getting that name from my alert controller from the first text field. So I'm using my compose alert, its text fields array, and the first array I'm accessing the first element of our text fields array, and I'm accessing the text property. And I'm also going to need the content for my message. So also creating a content object here using my compose alert, accessing the text fields, its last component now, its last element, because we only have two text fields, so we can use the last and the first, accessing the text property. And if both is available, what we can do is create a new suite. So since we have created our new suite or our suite struct, I can just say new suite and initialize my suite very, very conveniently using just my name, the content, and just a date object for my timestamp. And that is all there is to creating now a suite object in our using our data model. But now, how do we get that into the cloud database or into Firestore? And we're going to use a document reference, because when we're adding now our document, we do not really have an ID. We could use the timestamp, but sometimes there isn't a meaningful ID for a document, and it's more convenient to let Firestore auto-generate an ID for us. So what we can do is, first of all, creating a reference. Very simple. So just calling this ref. It's going to be an optional document reference, and I'm initializing that with nil. And now I can use my reference and use self, our database, doing that because we're using self because we're in a closure, so that is necessary. Now using a collection, and this is going to be our collection suites. So if this is not already created, then we're creating it when we're first calling that. So we have our collection suites now. Now I'm adding a document, which is going to be our suite. And as you can see, it is now requesting us, or it's required to pass along a dictionary. But what we can do now is simply using our new suite and call the dictionary property to give us a dictionary. And that's it. So now we have added a document with some data, and we should also check if this worked. So we're adding some curly braces here to add a closure. And I'm now checking, or first of all, creating an error parameter here in this closure that we can check. And then I'm using if let error equals error. So if we have an error object, then we can print, let's say error adding document, and we're passing along the error and its localized description. Else, if we do not get an error object, then we can say that we have successfully, or document added with an ID, and we can just use our reference and its document ID to check out which ID we gave our new suite actually. So what we've done is created a new collection, or adding a document to our new collection every time we are actually creating a new suite. And if we and we've also initialized our new suite object, passing that along as data to our new document. And by using this document reference, we are generating, or we let Firestore generate an ID for us, which is very convenient. So let me just run this in the simulator right now. So here we go, and now I'm pressing my Compose Suite button, and I can create a new suite. So I'm entering my name here, and my message, hello sweet world. And I hit the send button. And of course, we do not see any updates yet because we haven't implemented that, and we see just the placeholder table view cell. But what we can see here at the moment in the console is that we added a document with a specific ID. And if I now open my Firebase console in a browser and reload the database page, then I should be able to see a new collection, which is suites. And the cities collection is from the last video, but here I have a new collection called Suites, and I have my first document, and I have my content, my name, and a timestamp. So we have Hello Sweet World, my name, and the timestamp. Really, really cool. So this is how simple it is to actually send data to Firestore with just a few lines of code and with our data model, which makes our life so much easier because we can just pass along and create these objects as we're used to in Swift. So now that we have our first object, we can create a load data function for our table view controller, and there the suite array is going to become more interesting for us. So let's first of all create a function right below view.load. Let's call it load data and add some curly braces here, and then let's also directly call that after we have initialized our database. So I'm calling load data right here. And now to retrieve data from Firestore, this is so simple. We're just using our database object. We're accessing our collection, supplying it with a path. In our case, our collection that we'd like to access is suites, because this is the collection that we can also see right here, the suites collection. And we'd like to get all the documents that are in this suites collection at the moment. So all I need to do is call get documents and add a completion. So I can also just call the function here and add a completion closure right here and add the parameters that I really need, which is a query snapshot and an error object. So this is going to be our closure here that we're going to work with. And what we can do now is, first of all, I can check if we have an error. So we create a flat statement with an error object, assign our error parameter. And if we have an error object, then an error probably occurred. So I'm going to use string interpolation here, accessing my error object and its localized description to get to know what the problem really is. And in the else statement, I can now work with my data that I've received in the query snapshot. So since we are in a closure, I have to use self now and access my suite array. And I want to add now all of the suites that we received from our database. So I need to access my query snapshot, and since we had no error, I can be pretty sure that I can use it, so I'm force unwrapping it. Now I'm accessing its documents, and as you can see, this is an array of document snapshots. And since I want to convert that into our data model format, I can now use these documents and call flatmap and just transform the data or flatmap the data so in a way that we can use it by initializing a suite here with a dictionary. And I just have to access my object here using $0 and call the data function. And this initializes our suite, and we have now an array with all of the suites that are currently available in our Firestore database. And now I just have to reload my table view to actually display the data. So I'm using the dispatch queue. This is a user interface update. So I'm using the main thread, async, and I'm calling self table view. and reload my data. And we have to do a little bit of configuration here for this to work. So I'm scrolling down a little to my table view data source. And the first thing I need to do is not anymore returning just the number 1 here for number of rows in section, because we probably could have more rows in section depending on the number of suites we're downloading. And so I'm using my suite array and count the elements in this array. And then we also have to configure our Cellforrowatindexpath function. So I'm creating a new suite object here, and we can access our suite array using the index path and its row to access the appropriate array, or to access the appropriate suite for a specific cell in our table view. And if we have such a suite object, we can change our text label and its text property depending on what is the content of our suite. So here I'm first of all going to add a name. So I'm accessing my suite and its name property, adding a colon, and then after that I'm adding, again using string interpolation, using my suite and the content. And then I'm also accessing my cell and my detail text label and its text, so the subtitle, and here I'm just using my suite and the timestamp. And if I now run this in the simulator again, we should be able to see our first suite in our table view. So let's quickly have a look at that, and we are in luck here. So Brian said, "Hello, sweet world," just a few minutes ago. Now, when we now write a new suite, let's say Brian again here, and hello again, and I'm sending this, nothing really happens. But if we open up our console and reload that, then we should be able to see 2 suites. And indeed, we have hello, sweet world, and we have hello again. But this change isn't reflected in our user interface yet. But Firestar comes with this great real-time update feature, so we can listen for updates in our Firestore database. And this is what we're going to do right now. We're going to add one more function below load data, and we're calling it, let's say, check for updates. And we're also calling this function right after we have called load data in view.load. So here we're also checking for updates. And this is kind of a listener that listens the whole time while our app is running until we terminate it for updates in our database. So I'm just adding a few lines of code here, using my database again, using my collection, which is suites. And I'd also like to show you a little filter here, because as you've seen in the previous video, we have really great querying functions here. For example, I can say with a where field, and I can say where a specific field, like for example in our case timestamp, is greater than date. So we're only querying for updates that happened after we've called check for updates for the first time. And what I can do here now is call the add snapshot listener function, which is going to listen for changes in our suites collection and inform us about these changes, and may also changes happen and visible in the user interface. So I'm calling that function here and directly appending a closure with 2 parameters. First of all, a query snapshot, and also an error object that we can use. And first of all, I'd like to check if we got a snapshot back. So I'm using guard let statement here, creating a snapshot object, assigning my query snapshot. And if that works, it's fine, we can continue. But if not, we should definitely just return. We could also print an error here, but I'm just satisfied with returning right here. And now it's really, really cool, because we can now use our snapshot object and just go through the document changes. And then we can even call the for each function, and again append a closure here with the difference that the diff that we can use here. And this diff even has several different states or types. So I can check if the diff and its type is equal to added, for example, or we even have removed or updated, then I'd like to do something. And I'm again satisfied just by checking for the added type. So every time we added something, we actually want to append this difference, what actually was added, to our list, to our suite array. So I'm using my suite array with a self because we were in a closure, and I'm just appending a new element. And here I'm using, again, my suite data type, initializing it with a dictionary, and here I can now use the div, its document, and the data to actually create a suite object. And here I just have to unwrap my suite, and then we can continue using the dispatch queue again, using main async, because now we have to reload our data using the table view, reload data to actually show what was changed. And this is how simple it is to listen for changes and only add something when there really is a change, and only if the difference type is added. So this is extremely easy to handle and really, really cool. So I'm now running this again in the simulator, and if this works, then we actually should see a change reflected immediately after we composed a new suite. So here we go. I'm entering again my name, and I am excited is my message, and I'm sending it, and here it is. So it's as simple really as that. And now I'm going to run this on my physical device. So now I have composed a second message with the name Brian2 on my second device, and I'm now sending this to our Firestore database, and now it already appeared in our simulator. So this is amazing how fast this works and how easy it is to implement such a great sync feature. But if you're still tuned in and if you're still following, then I'd like to show you one more thing that's incredible. Because if I now turn off my Wi-Fi, and as you can see, or it should be reflected in a second in the simulator, or you can at least take my word for it, and I've just closed my application. And I really do not have an active internet connection at the moment, even though we're seeing the Wi-Fi symbol here in the simulator, but there is no connection. So if I were to open up a website here, let's say the iPhone user guide, as you can see, there is no internet connection. But if I now open up my Firestar app, then you can see that the data is still here, and we still get all of our suites here, although there is no active internet connection. And I'm now sending another suite from my second device, and of course we do not see any change here. But let me just activate my Wi-Fi on my computer again, and we should immediately see a change here in our user interface as soon as the iPhone also has noticed that we again have an internet connection. So let's just wait a second or two, and this change should be reflected in our user interface. And indeed, here we go. We got Brian3 with test2, and this happened automatically because our application noticed that the connection was back again, and Firestore automatically fetched that data for us. So this is really incredible. I'm so excited that Google came up with Firestore and all these changes to what we already got from the real-time database, and now we got this. So this is really, really cool. I hope you're as excited as I am. Let me know in the comments below. Also, check out the other video about the basics of Firestore if you haven't seen them yet. Make sure to subscribe to not miss anything, and thank you so much for watching. Bye-bye.